Regression analysis. So we're going to look at what is called linear regression. Linear has to do with two variables. When you're dealing with more than two variables, we call it multiple regression. So for linear regression, we're dealing with variables x and y. Y is what we call the dependent variable. X is what is called the independent variable. The dependent variable depends on the other. So regression is very important in our day-to-day lives because it helps us understand how two variables are related. For instance, you're a marketer and you want to know the relationship between what? Sales and advertising. So your sales will be the dependent variable because sales depend on what? Advertising. So you need to identify what your dependent and independent variables are. So using what we call the regression equation, we have A, which stands for the what? The y-intercept. The y-intercept is a cutting point where it's cutting y. So this is called our A. A. Now, we also have another important variable here, which is called the slope or the gradient. This is our gradient. The change in y over the change in x is called the gradient. Now, relationships can be typified by a regression equation. So if the relationship is positive, we use what is called the R, which is the coefficient of correlation, simply to tell you whether you have a positive relationship or a negative relationship. Examples of positive relationships are what? The supply function, it's upsloping. Also, we have what is called the coefficient of determination, which tells you whether you have a strong relationship or a weak relationship. The points, if you're going to plot them and they're going to be close to each other, this is called a strong relationship. If you have 0.90, it means 90% of y is affected by what? By x. It's a strong relationship. It can also be a weak relationship, like 10%, which is 0.10. This is a weak relationship. The dots will be further away from each other. Although it's positive, but weak. So this is a positive relationship, but what? Strong. So our R squared is more than 50%. This is still a positive, but a what? A weak relationship. Our R squared is less than 50%. So whenever our R, which is the coefficient of determination, is positive, the slope as well will be positive. Whenever our slope is negative, it looks like it's downsloping. An example of a downsloping is a demand function. From our economics, demand has a negative slope because once one variable is going up, the other one is going down. You're able to tell. So likewise, even this one can have a strong negative relationship. This is negative because our R, coefficient of determination, is negative. But if we get more than 50%, this is what? 0.5 greater than 50% is strong. As well, our R can be negative, but if our R squared is less than 50%, it is a weak negative relationship, meaning the dots are apart. Sometimes you have no relationship at all, meaning the dots are scattered, there's no order. So R is equal to 0. So the formulas are as follows. Our R, sum of square xy over sum of square xx times sum of square yy. We could have our slope as sum of square xy over sum of square xx. And our slope is summation of y over n minus the slope summation of x over n. So this is a formula. Now, We're going to look at an example. So the formula for xx is just an array of x's. Yy, arrays of yy's. And now xy, you have xy on each. But the question here, question number 1, we're asked to plot. Of course, you're able to tell whether it's a positive relationship if the variables are increasing on both sides. Even this one is increasing. It's a positive relationship. You can plot this and sketch it if you want. 1, 2, 3, 4, 5. 1, 2, 3, 4. So we are being asked to sketch. So the first one is what? 1, 1. 1, 1, you put it here. The second one, so we're looking at x and y. The first point is 1, 1. The next one is 1, 2. 1, 2. 1, 1. Then this is 2, 1. 1, 2, 3, 4, 5. And here is 1, 1, 2, 2, and 4. So this is 2, 1. So you put here 2, 1. This is 3, 2. 3 under 2 here. And finally, 4, 2 and 5, 4. So you can tell this is our, it's an upsloping. It's upsloping. It's going upwards. It's a positive upsloping. Then question number 2, for part B, find the regression equation. So to find the regression equation, sometimes they ask you to find the prediction equation. It's the same thing. So firstly, we need to find or fill in the following table. Here we have x squared. Here we have y squared. So here xy, what do we have here? 1, 2. Just multiplying this column and that column. 6. Here we have 8, 20. And here we're squaring each of these ones here. This is 1, 4, 9, 16, 25. And here, 1, 1, 4, 4, and what? 16. So we total up now. What is the total for this column? Summation of x, what do we have? 5, 10, 15. So here we have 15. Here what do we have? 10. Here what do we have? 37. Here what do we have? 55. Here what do we have? 96. Summation of x is 15. Summation of y is 10. And summation of xy is 37. Summation of x squared is 55. And summation of y squared 26. And our n, how many pairs we have? 1, 2, 3, 4, 5. Our n is 5. Are we clear so far?
Yes.
Then we'll be asked to calculate the sum of squares. Sum of squares here, where there's x squared here, we're going to put what? 55. Minus summation of x was what? 15 squared divided by our n, which is what? 5. So 15 times 15, which is 225 divided by 5, we get 45. So 55 minus 45, we get our 10. This is the sum of square xx. Sum of square xy is 37 minus sum of square x, summation of x, 15, and y, 10 over what? 5. 5 in there, 2 times 30, 2 times 5, 15 is 30. So 37 minus 30, we get a 7. So this is our sum of square xx. This is our sum of square xy. And sum of square yy, our y squared is what? 96. Minus summation of y to the power 2. So 10 to the power 2 over 5. So 10 into 100 is 20. And 6 minus 20 is what? 6. So this is the sum of square what? Yy. So these are the preliminary calculations you need. All right. So to find the regression equation, we know that y is equal to what? A plus bx. So we need to first find our b before we find our a. Our b is sum of square xy over sum of square xx. From our calculation, what was our xy? Xy was 7, and our xx was 10. So we have 7 divided by 10, which gives you 0. What? 0.7. Are we together?
Yes, we are.
Then to find the a, which is the y-intercept, summation of y, b, summation of x over n. So summation of y, 10 divided by 5. Our b, we just got it as 0.7. Here we have 15 over 5. This is 2 minus 2.1. So our a is negative what? 0.1. So meaning we just substitute where there is a, we put negative 0.1. And b is 0.7. So look at that, digest it. So you needed to know the formulas. Okay. So this is our second part, part B. Part C, they'll ask you to substitute. For instance, they'll say, if x is 10, find y, predict y. So y, where there's 10, we're going to put what? That is x, we're going to put 10. So if we put our 10 there, we're going to have y is equal to 6.9. In part D, find r and r squared and comment on it. So we know that r is sum of square xy over sum of square xx times sum of square yy square root. So our xy, if we go here, was 7. Xx 10, yy 6. So it's 7 over 10 times 6. 7 root 10 times 6. Square root that, going to get 903. So here we're interested in the sign. So simply say x and y are positively related. X and y are what? Are positively related. Because of the positive sign. If you got negative, let's say they have a negative relationship. Here they are positive, or they have a direct relationship. And r squared 0.903, we square this answer. We're going to get what? 0.816. So this means 1.6% of the variation y is influenced by x. So in short, 81% of y is affected by x. So this is how easy regression analysis is. So we now want to look at how to use a calculator to get the figures. So using a Casio calculator, you're going to press mode, and 3 would depict a regression, then 1 linear. So like that, you're in linear regression mode. Now you need to be entering the data sets as pairs. So when you press 1, 1, you go to m plus. 2, 1, m plus. The figures I'm giving you are coming from our x and y values. 2, 1, m plus. Please don't press the plus button, but the m plus, because students have the tendency of making a mistake. 3, 2, m plus, 4, 2, m plus, and 5, 4, m plus. Your sample size showing must be n is equal to 5. So to show the workings, you now go to second function, which is also called shift. You press shift button and you press the 1 button. The 1 button shows you all the workings. It's like a manual. Shows you what you need. So 1, then 3 things will sprout out. Summation of x squared is on button 1. Then press equals afterwards, so that it gives you what the summation of x squared is. Then again, you go to shift 1. To find the summation of x, you press button 2. Don't forget to press the equal button. It will give you the figures. Then shift 1 and button 3 is your n. Although this is not important, you may want to verify whether the sample size is correct. So let's go in that order. Shift 1, then button 1 equals. Then you should get 55. Is that what you're getting?
Yes.
Yes.
Then you go shift 1, 2 equals. Our summation of x was what? We're just verifying the answers we have here. Summation of x was 15. So you should get what? 15. Is that what you're getting?
Yes.
Then shift 1, then 3. It will give you n, which is fine. Of course, we know our sample size is fine. So this is for the what? For the workings. But you see that the y's are not being depicted here. So to find the y, after you press shift 1, you go to the right arrow. is this seemingly this shape here, the right arrow. You can press it to show you what is on the other page. So it will show you summation of y squared, summation of xy. So it is on 1, that is y squared, on 2, that is xy. Is it?
Yes.
So what is your y squared?
26.
26. And what is your xy?
10.
10. So this functionality is as good as you use your DSTV. Just a remote control.
Sorry, how did you say you get the Y? I missed that one.
You go to the next page by pressing Shift, then you go to 1, then you go to the right arrow here, so that you see what is on the other page. Then you find those options. You choose according to the number you want. Are you there?
So you said shift. You shift.
Shift 1,
Uh-huh.
then you press this right arrow. Then you look for x squared, y squared, and xy. You choose it according to the numbers.
Okay, I'm not getting any options when I
You
press on
press the right arrow until you get the options you're looking for.
I'm not getting anything when I press the right arrow.
But did you get the first arrow when you press Shift 1? Are you getting what we got?
Yeah,
Whenever you make
all the Y, everything was okay.
the X, everything is okay?
Yes, I mean, yeah, for the X, everything was okay.
Then unless then you now go to Shift 1,
Mm-hmm.
then press
Okay,
this arrow.
Ah, okay, that's fine.
Unless the
Then
button was not working, then you choose what you want. Have you seen them?
yeah, it's okay now.
All right. So now to get the final answers.
For me, on the EXY, it's giving me 37.
Yes, that's the correct answer. EXY is 37. Then summation of y is on 3. Is on what?
No, summation of y is on 2.
Summation of y is on 2. Uh-huh.
That's the 10.
That's a 10, okay?
Yeah.
Then summation of xy.
xy is 37.
On 3. Is that 7? Okay, are we together so far? And now let's go to Shift and 2 to get final answers. Shift 2, then you do 2 right arrows. Shift 2, then you get 2 right arrows. Then look for A, B, and R. I'll guide you step by step on that one. I just want you to help me find A, B, and R. And we'll square the R. It will give you R squared. So go to Shift 2 and 2 right arrows until you press the right arrows until you find what you're looking for. So I'll get to the sharp calculation after I'm done with this. So this is 0. What? It will give you
0.1.
0.1 negative. Then the B,
0.7.
0.7. And the R,
0.9.
903. You square this
0.3,
answer.
yeah.
There's no R squared, just square the answer.
Or square root the answer.
Square, not square root.
Or square.
0.816.
0.816. Yes.
Okay. Is that okay? Is that clear?
Yes.
So are those the answers we got? They're the ones we got here. So in case you decide to forget the formulas, that can help you guide you. This is what you're supposed to get. Now, when it comes to regression, the smartest calculator, the most sharp calculator is sharp. So for sharp calculator, you press mod, then 11, mod, then 11. Are you there? Those that are using the sharp?
Yes.
Mod, then 11. Then you start entering the pairs as well. 1, your comma is on store. So 1, store 1, m plus. 2, store 1, m plus. So you need to enter all those data until you reach 5, 4. So your comma is store. Are you there? So quickly do that.
Yes.
Yeah.
Until you reach n is equal to 5. Are you there where it's n is equal to 5?
Where's the
Where's the?
M1?
Just certify n there. M1 is here. After store, there's M1 here. So 1, store 1, m plus. 2, 1, m plus. You do the same until the final.
I found my file.
Are you there?
Yes.
So after you do that, for you, you're just using alpha directly. So you see alpha and you see the blue things here. So you go alpha, decimal point equals. It will give you summation of x. Alpha plus or minus, there's summation of x squared there. Press equals. You get what you're looking for. So around here, you find x, y squared, and x, summation of x and xy. Even r and abr, they're all here. A, B, and R. So whatever you're looking for, just do direct. There's no much procedure for you. So quickly, give me the summation of x. What are you getting? So alpha, decimal point, then answer. Remember, everything that is in blue is going with alpha.
55.
5 good. Then summation of x squared. Alpha that equals, what are you getting?
Only 15.
Excellent.
Then summation x squared 55.
About A, alpha open brackets equals, you should get negative 0.1. Is that correct?
Correct.
Yeah, etc., etc. So now we can go to a question. So we can now shift to probability. We said we have 5 probability distributions. We have the binomial, we have the Poisson, we have what is called normal distribution, we also have the discrete random variables, we also have what I call the exponential and the mass functions. So the mass functions and the random variables are very closely related. So we have what is called the expected value, which is a mean. It's simply multiplying the values of x with their respective probabilities. And also we have the summation of x squared px minus a mean, and when we square root variance, we get the standard deviation. So I love to use a table. A simplifies my life so much. So this is the easiest probability distribution once you get exactly how I get it. So we have these columns. Probability, you must make sure that it's adding up to what? 1. So here we have 2, 4, 6, and 8. We have the probabilities here. We have 0.1, 0.3, 0.1, 0.4, 0.2. And you simply multiply this by that, is 0.6. 0.4 plus times that, 0.4. This by that, 2.4. And this by that, 1.6. We add,
Excuse me.
yes,
Are we putting those figures in the right columns? I mean,
no.
X, there's, yeah.
No, we are not.
Okay. We're not putting in the right column. Thanks for that. So we're supposed to put them here. So this is XPX. It's got to be there. Thanks for the clarity. So here, when you add this is 1 and this is 4. So we're going to get 5.0. So 1 plus 4 is 5.0. This is called our mean summation of X. Our mean is 5. Get our 3 marks for that. Then we now start squaring this column. So this is what? 4, 16, 86, and 64. And we multiply this by the probability. We have 1.2. This by the probability is 1.6. This by the probability, what are we getting? This by the probability, what are we getting? 4.8. Here, what are we getting? 14.4. And we add up 0, carry 2 is 14, 15, 16. So we have 30. So this is summation of what? X squared px. So we subtract this one minus the square of that, we get the variance. For 30 minus 5 squared is 30 minus 25, which is 5. The variance is equal to what? 5. Derivate the variance, you get the standard deviation. And what is the square root of 5? 2 point what? That is the square root of 5.
2.23.
0.33. Here we're told to find the probability greater than 4. So which numbers are greater than 4? Probability of what? 6 plus the probability of what? 8. When we add this, probability of 6 is 0.4, probability of 8 is 0.2. We're going to get 0.6. So this is a probability. If they say at least 4, so starting from 4 going upwards, so I've added this plus that, we're going to get 0.7. They said at most 4, it means 4 and below. That I found 0.1 and 0.3, which is 0. What? 0.4. So aligning this to our exam paper, we're asked to calculate the expected number of arrivals, 3 marks, and the standard deviation, 6 marks. Can you fail to do this? So here, given the frequencies here, so if you just total up this, you're going to get what? 200. Then the frequency is the probability. So 14 over 200, you find 0 point something. That's a probability. That 1 over 200, you're finding the decimal point probability. Then you do exactly what we did. Find the variance and the standard deviation. I'm not going to solve this one for you, but you get the concept?
Excuse me,
Yes.
Yes, please, there's a question.
can you repeat question? Can you repeat question number 4?
I repeat question number.
Number 4 on the example that we're going through.
Example that we're going through here. Probability greater than 4. So what are the values of x that are more than 4? It is 6 and 8. So you put probability of 6 and 8, then you add their actual probabilities. The probability of 6 is 0.4 plus the probability of 8 is 0.2. Okay, is that clear?
Yes.
So there are times when we are actually not given. So here we're given what? 2, 4, 6, and 8. And you're actually given the frequencies. 1, 3, 4, and 6. 1, 3, 4, and 2. So here, this is the total is what? 10. We divide 1 over 10, becomes the probability. So this is 0.1. 3 over 10, 0.3. 4 over 10, 0.4. And 2 over 10 is 0.2. And you now continue doing the process we're doing now. So xpx is 0.2, 1.2, 2.4, finally 1.6. Want to total up there? 431, 5.4. This is our expected value. To find the variance, square these columns first. Square, we have what? 2, 4, 4, 16, 36, 64. And we multiply this by the probability 0.4. This by the probability 4.8. With 6 by that one, what we get? 14.4. This one by that one, we're getting 12.8. So 32. So we have it's 2.4. So this minus the square of that is called the standard deviation. So the expected value is what? 5.4. variance is 32.4 minus 5.4 squared. Then when you square root the answer, you get a standard deviation. So this is exactly what was supposed to be done here. Is this clear now?
Yes.
All right. Now we go to descriptive statistics. So we may have 0, 1, 0, 2, 0, 3, 1, 2, 5, 1, 3, 5, 7. What is 10 plus 9? Here we have
19,
15, 12, 18, 21, 40, 26, 8, 81, 1, 22, 26, 34, 30, 32, 31, 36. So you'll be asked to draw a stem and leaf diagram from this table. So we start with numbers that start with 0. We have numbers that start with what? Ones. We have numbers that start with 2, 3, and 4. This is called the stem. And this is called the leaf. So let's start with numbers that start with 0. We have 0, 1. So instead of writing 0, 1, and you put 0, 1, there's already a 0 there. 0, 2, we put a 2 there. And we have 0, 3. In the order, they are ascending. So for the ones, which one is the smallest on the ones?
the
So once
12,
you do that,
So
we have what? 12. So 1, 2,
12,
and the other one, another 12.
12, 15, 1, 5,
1, 5.
8,
1, 8. Correct. Then
we have 21,
21. So 2, 1.
26,
Another 21.
2,
Then 22.
and 26,
Mhm. Then
26,
26. Have you omitted anything? Then 26.
and 28.
28. Then on the 30s,
30, 31, 31, 32.
Two.
I don't know if that's a 34.
yes, 34,
Yeah.
And
36
36,
and another 36.
36. Then on the 40s,
40 itself.
40 itself. So what is our n? How many are they?
There are 5. Or in total.
We are 20, right?
Yes.
20. So let's find our range. Range is the highest number minus the smallest number. So what is our highest number?
It's a 40.
The smallest number?
It's a 0.
Yes. So are you sure?
0, 1.
0, 1, 1.
So range is the highest value, the maximum value of x minus the minimum value of x. So here we have what? 40 minus what?
1.
0, 1. What do we get?
39.
Great. Then the mode is the most appearing number. Which numbers appear the most? Yeah, these ones, these ones, these ones. Please don't embarrass me on record. What number is this?
That's a 12.
Good. 12. Then
21,
21. Excellent. Then
31,
31. Then
and 56.
36. Good.
36.
If 6 was appearing, had another 6 here, it would have been the highest number. These ones are the highest appearing twice. Then we go to what are called the quartiles. Q1 is called the lower quartile. So it is a quarter of n plus 1. Our n is 20. 20 plus 1 is what?
21.
So a quarter of 21. 5 point what?
5.25.
The nearest is 5, the whole number. So let's count the fifth number. 1, 2, 3, 4, 5. What number is that?
4.
4. Good. Q1 is 12. Q2 is a median. It is half of n plus 1.
Plus 1.
So our n plus 1 is 21. Half of 21 is what? 10.5. Now a 0.5 means you get the 10th number and the 11th number, you divide by 2. So 0.5 means you get that number and the following one, divide by 2. If it was 11.5, the 11th and the 12th, divide by 2. So here we're going to get the 10th and the following. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. What numbers are these?
22 and 26.
22 and 26. Then you divide by what?
2.
What do you get?
We get 24.
Excellent. And Q3 is 3 quarters. What is 3 quarters of 21? 3 quarters of n plus 1.
Seven.
7 point what?
It's just 7.
20.
Can't be 7.
Oh, 3 quarters.
should be
It's 15.75.
0.2.
So how do you round this one off?
You go to the next, which is 16, because 75 is above 50.
So the 16th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. What number is this?
32.
82. Excellent. Right. So now to find the interquartile range, it is the upper quartile
Minus the lower quartile.
So our upper quartile is 32. The lower quartile is 12. What is 32 minus 12? 20. And we have what we call quartile deviation. Is half of the interquartile range. So half of 20, you get what? 10. Okay. It's got the interquartile. It's got the quartile deviation. No, it's got the semi-quartile deviation. Semi. QD is the same as interquartile range. But semi-quartile deviation, it means half. Then we have what we call the box whisker diagram. It has three ports.
The whisker diagram.
The whisker diagram has number 1,
The
the
whisker,
minimum value X,
the bar action,
Box plot.
both plot or whisker.
then the maximum, then we have what we call Q1,
Q1,
Q2,
Q2,
Q3.
and Q3.
So our Q1 was 12. Okay, and our Q3 was what? 32. Our smallest value was 0, 1.
01.
Here we had what? 40.
And the mass is 40.
Then the Q2, which was the median, Q2 is also called the median. Was what?
24.
24.
So we
This is the box whisker diagram.
Is the difference?
Sometimes you'll be asked to identify the outliers. So the outliers, we first find what is called the correction term.
1.5 minus
IQR. So if you first find 1.5 IQR, then you subtract it from each of the quartiles. 1.5, the IQR was what? 20. So you get what? 30. So you subtract the lower quartile minus 1.5 IQR,
Sorry, what did you say the IQR is again?
the interquartile range. Yeah, the
Oh,
quartile deviation.
Okay.
When we multiply by 1.5, we're getting the correction term, which we're going to subtract and add. So 1.5 IQR, so 30 minus this part. You
it's
get
negative
what?
18.
You get negative what?
18. One, yes, negative 18.
So the interquartile, the outlier is here. In numbers, and here we add the upper quartile plus 1.5 R. So you get what? You add
Colin, sorry.
the 30
Colin,
with
sorry.
We get 62.
62. Good.
Colin,
Yes, please.
I think we're having a lot of feedback. Some people put their mics on, so
Okay. So after finding that then we'll be asked to find our mean. Mean for the ungroup data is given by summation of x over n. Now, since I taught you how to use a calculator, you can also enter the data on the calculator by doing mod 10. Mod 10. What are you having? SD. When you go to mod, what is appearing there? The cursor calculator.
Comp, SD, and range,
Yes. So
and
SD.
regression, sorry,
SD is on what?
2.
2. So for the cursor, you press mod then 2.
Mhm.
Then start entering. 01 m plus. There's no comma here. 02 m plus. 03 m plus. Then 4
So for the Casio, you said mod.
mod then 2.
Then sharp.
The sharp, when you press mod, what is appearing?
No more than start.
Yes, you press start. Start is on what?
On 1,
Yes. So mod 1. Then what is appearing?
then SD 0, line 1, squad 2.
Yes. So another one on SD. SD is on 1, right?
On SD,
SD is on
SD is on 0.
yes 0. So you
Yes.
press mod 10. Yeah. So 0. So start entering them.
So I press what? 0?
Yes, 0. That is statistics mode.
Okay, so it shows start 0.
Yes, so that is 0. Now start entering them. So 1 m plus, 2 m plus, 3 m plus. This is 12 m plus, 12 m plus, 15 m plus, 18 m plus, 21 m plus, 21 m plus, 22 m plus. So enter everything until you reach 40. So it should give me
Collins, kindly check the picture I've sent to you. Maybe if this calculator I've sent can do this is what we're entering on the Casio and the Sharp calculator.
okay. Let me check. But whilst I'm checking, yes, even this one is okay.
So like for
This one is like
mod,
a sharp calculator. So mode, what's appearing?
there's comp, start, equation,
Yes, go to
table.
start.
Okay.
Mhm.
Then there's -1 VAR plus BX. There are quite a lot of confusing equations here.
It's complicated.
Yeah.
Yeah, do the manual way. Sorry.
Okay.
So those that are still doing, what are we getting?
Collins, just a minute. So you for the Casio, you said mod S2, which is SD, isn't it? Now where you go to 0.
Yes. Just 01, 02, 03. So 01 m plus, 02 m plus, 03 m plus. There's no comma. 1, 2.
Okay,
m
so
plus.
after I'm done with 03, what's the next?
Continue. This is what? 1, 2 m plus.
Then 1, 2. Oh, okay, okay.
Until you reach the last one, there should be 20. The n must be 20.
Okay. All right.
Mr. Collins, you can't see the figures. Maybe if you can shift to the left so that we can see the figures.
The figures? You all can't see the figures.
Yeah, for the stem and leaf.
I can't shift them any.
We can see them.
But they're visible.
I can't see like everything.
Can somebody screenshot and send on the group for him? Because they're visible on my end.
They are visible.
Somebody screenshot and send. Thank you. So what is summation of x?
$451.
451. Okay. Then x squared.
One 12,871.
Then when you go to shift 2, it will show you the standard deviation and the variance. So shift 2, our mean is what? So press shift 2, x bar is on 1, isn't it?
Yes.
What's the answer? 20.
22.55.
0.55, good. Then our standard deviation looks something like this, xn minus 1 here. What are you getting? Or for the others, sx. What are you getting?
11.92.
I'm getting 12.
Pardon?
I'm getting 12.26.
11.9.
Make sure it has an n minus 1. Or it is sample standard deviation sx. What are you getting?
12.26.
Calling
Yes, please.
on my calculator is showing SX.
Yes, sx. What is sx? Please, there's population standard deviation. This one is population. We are looking for the s. What are you getting?
SX is giving me 11.922.
90. All right.
I'm getting the same figure as well.
90. Let's use the manual.
Just a minute. For me, the EX, I'm getting 453. Then AX squared, I'm getting 13,035. And then the X bar, I was getting 22.656. Then the SX 12.08.
Is there anyone getting what she's getting?
I think she maybe made a mistake when entering the number.
Yes, maybe there could have been an error. Okay, let's get the
Yeah.
principle for now. So is that okay?
Okay.
Yeah.
Yes.
So here you get what? What was summation of x? Summation of x was what? 451.
451.
451.
Our n,
20.
20.
20, and our summation of x squared,
12,871.
pardon?
12,871.
4,871. So here we're going to have 451 divided by n, which is 20. What are you getting?
22.55.
22.55.
2.5. And the standard deviation, the formula is what? Summation of x minus summation of x squared so x to the power 2 over n minus 1. So here we're going to put 4871 minus 451 squared over 20 minus 1. What are you getting? Reverse that from
So
squaring
the
this. 451 squared
451
over 20.
squared, when you divide 451 squared by 20, it's giving 10,170.05.
So here what do we get?
We're getting 27,000.
No,
27,000.95.
0.95.
So I'm removing those that haven't made payment here. 27 point.
27,000.95.
As a final answer. How can it be 27,000.95?
Divide by 19, which is
The final
142.
142.155.
142.155.
Then when you square root it, what are you getting?
11.922.
11.922.
11.922. So
2.
who got this one here now? We can settle the argument. Okay. So you see now where it is. The population doesn't have n minus 1, just has n on top. Okay. So now that is where we get our standard deviation in the variance. Then we have what we call coefficient of variation, which is standard deviation over the mean times 100. So what do we have? 11.92 over 2.55 times 100. What do we get?
$52.87.
52.87%. Then we go to our what? Coefficient of skewness. 3 mean minus median over standard deviation. So 3, what is our mean? It's 2.55.
22.55.
Median, the second quarter, was what? Median was what?
24.
Second quarter, which is 24.
24.
And the standard deviation is what? 11.92.
922.
So here, what are you getting? Negative 0.36.
Negative 0.36.
So the sign here says if you get a negative, it's negatively skewed or skewed to the left. So skewness shows you echo finina. If you get 0, it's normally distributed. If you get negative, it's skewed to the left or negatively skewed. Get positive, it's positively skewed or skewed to the
Right.
right. Okay. Are we clear?
Yes.
Information overload.
No, I can't. I'm not getting 0.36 when I compute. I don't know if I'm doing it the wrong way.
You get the answer on top there. If you don't use board mass, it will be wrong. So 3 open brackets, put it directly, it will be 3. What are you getting here? 22.55. What?
Mhm.
Negative.
2.55 minus 4. Negative
22.55.
1.25.
This is not 2, this is
Negative
22. Negative 1.45.
1.45.
Then divided by 11.92.
Okay.
You're getting?
Okay, I've gotten it.
All right. So now,
Collins, I have a question.
Mhm.
How does one read the skewness using the stem and leaf diagram?
you can tell from the stem and leaf diagram, you know how to draw the histogram. If you tilt this upside down,
Okay.
this one will be how? We're going to have something like
So
this.
it's on the left.
Yeah.
Yeah.
How many?
There are 3.
Yes, we have 3. So you're seeing it's shuffling in a left time. You can
Yeah.
see that.
Yeah. Okay.
So this is 3, 4, 5, 7, 1.
Mhm. Okay.
Now we can convert this into group data. This was under ungroup data. So 0 to 9, 10 to 19, 20 to 29, 30 to 39, 40 to 49. So total is here. So this is a class. Then we go to frequency. 0 to 9, we had 3. 9, 10 to 19. Number ones, we had how many? 4. Then here we had 5, we had 7, we had 1. The total was coming to what? 20.
The total is coming to 20.
All right. Then we had the cumulative frequency. That's the cumulative frequency. We have 3 here. We add 4, we get 7.
7,
We add 12,
12,
we get 12. We get 19
we get 19,
and 20 here.
and 20.
Get the midpoint. 0 plus 9,
9,
9 divided by 2,
4.5.
4.5. Then 10 plus 19, 29 divided by 2, 14.1.
14.5.
So the height, don't subtract this one aside, you get the difference. It's safer like that. The height is what?
Sorry, how did you get the cumulative frequency?
Okay. We bring the first one. 3 here is 3. Then 3 plus 4, 7. 7 plus 5, 12. 12 plus 7, 19. 19 plus 1, 20.
Okay.
And the height, you just find the difference between each one of these ones here. 10, 10, 10. And here you just find the first one here. 0 plus 9, 4.5. Then keep adding 10. Plus 10, 14.5. Plus 10, 24.5. Plus 10, 34.5. Plus 10, 4.5. You can still add this plus that equals divided by 2. It's the same answer you're getting.
Excuse me. How did we get the classes? Like, how did we come up with the classes?
Unless otherwise informed, you can assume the classes,
The stem and leaf.
the stem and leaf diagram here. So the zeros, I want 1, 2, 3. So 0, 0, 9, how many zeros? Yeah, 3. Then 10 to 19. Number ones, how many are they? 1, 2, 3, 4. Then we have what? 20 to 29. 1, 2, 3, 4, 5. Then 30 to 39. We have 7. 40, 49. Sometimes the examiner will tell you, use a class width of 5. You will be taught. Not closed, you can use according to the what? The stem and leaf diagram. Is that clear?
Sorry, just
Yes.
repeat on the 0, 0 to 09, how you started.
So all zeros, yeah. How many are they? 1, 2, 3. There are 3 of them. Number ones from things starting with ones from 10 to 19. 1, 2, 3, 4. There are 4. 20 to 29. 1, 2, 3, 4, 5. There are 5. Okay, all these are 20s. 30s from 30 to 39. 1, 2, 3, 4, 5, 6, 7. 40s 1. But sometimes say in class width of what? Of 5. You get the highest number and the smallest number, and you divide by the number of classes that they want you to have. So if they say in classes of 3, you divide this by 3. What are you going to get? 13. So many class widths you get 13. If they tell you in 5 classes, you divide 39 by 5, which is approximately 7 or 8. So that can be dictated. But if it's open, you can choose what is easier for you. Is that clear?
Yes.
Yeah.
So here we are now squaring. 12 squared is what? 1.45 squared, what are you getting? 20, 0.4, that is
What are you
0.25.
calculating?
square this one here.
20.25.
Oh, square.
0.25.
Squaring.
Okay. Then fx and fx squared. Then you multiply this one times the f. What are you getting? 20.25 times 3. No, you start with 4.5 times 3. What are you getting?
13.5.
1.5.
Again, 3 times 20.25.
60.75.
60.75. Here, let me mention the mistake students make. They want to square this to get that. Never do that. There's a point here and a point here. We're just doing 3 times that, we get the answer. Again, 3 times that, we get the answer. 4 times that, we get the answer. 4 times the other one, we get the answer. All right? But I don't want to proceed here. I'll just assume numbers here. Maybe here we have what? The total is 100. Here we have 1,000. The interest of time. Let's start with the mode. Mode means the highest frequency. L plus, I'll give you a shortcut method, D1 over D1 plus D2 times height. So the first thing is find the highest frequency here. It's 7. All right. So this is your FM. On top of it, F1. Below it, F2. I left this column deliberately because we have to adjust these classes. These numbers must be the same in the diagonals. So the rule is that you need to add a 0.5 on the upper bound. So this is 9.5. This is 19.5. This is 29.5. Then this is the 9.5. Then this is for 9.5. Then you subtract 0.5 from this side. So actually paranai. So this would be what? The 9.5. It's the same as that one. So even without looking, you know that this one will come down here. And 9.5. And 19.5. Then this is 9.5. And here's negative 0.5. Is that clear so far? Any questions at this point?
Yes.
Any questions?
No questions, I think.
There's a question in the chat box.
Yeah, what's the question?
Where did the three
come from?
Which 3?
Oh, I want the formula for
These 3
the skewness, coefficient of skewness.
is part of the formula. Part of the formula. Is that clear? So the formula for the mode. Formula for the mode. Unless there's any other questions before I proceed. Mo, are you clarified? Is there another question?
Colin, sorry, I've just forgotten. How did we get the 20.25?
20.25.
Yes.
Which one is it? Where is the 20.25 coming from? This one here?
Yes, that one.
Who can answer that?
The x squared, the 4.5 squared.
Okay, thank you.
We're squaring column 2 squared, so it's column 2 times column 2. Then this one is column what? Column 1 times column 2. This one is column 1 times column what? Column 3. Okay, so mod is L plus Fm minus F1 over 2Fm minus F1 minus F2 times height. This is a formula you find you're given. But the simplest is you find the distance on top. D1 is the distance from 7 to 5. What is our D1? 2. Are we together? So for the mod, we said identify the highest number first, which is Fm. On top of it is F1. Below it is F2. In the same line, L is a lower bound, which is 29.5. So you can choose to substitute that. So we're going to have our L is what? 29.5 plus Fm is 7 minus what? 5 over 2Fm, 27 minus 5 minus what? F1, which is 1, times the height of what? 10. So here you get the answer. That is how we find our mod. Or D1 is the distance above. So this from there, it is 2. The distance below, D1, Fm minus F2, this is what? 6. So you add the distance on top, 2 plus 6, you get what? 8. We're going to have 29.5 plus 2 over 8 times the height of what? 10. Don't touch this guy until you rectify this issue. 2 times 10, 20. 20 divided by 8 is 2.5. So here 29 plus 2.5, which will give you, pardon? 29.5,
32.
which will give you what? 32. Yes. The same answer is what you would get if you're going to do it this other way around.
32.
32. All right. Then we go to the median. Median is L plus N over 2 F calculated Fm times height. So we go to the same parameters we have here. Our L is 29.5. Our Fm is 7. Our F1 is 5. And our FC is next to F1, which is 12. So Fm is what? 7. L 9.5. Height is 10. FC is next to the 5, which is 12. Our N is 20. So our N is similar summation of F, which is 20. So this is 29.5 plus 20 over 2 minus FC is 12. Okay. Divided by Fm, which is 7 times height, okay, which is 10. And you get your final answer there.